Hey, hi. So basically, as of now, we are done with the image-based analysis, and also we have done with the symptom-based analysis. Okay. So now you can upload any lung X-ray or CT scan images. It will do the analysis and it will detect and classify the lung cancer or tumor from the X-ray image. As well as we have created one symptom-based analysis model also with the help of machine learning. It is also able to, from your information and symptoms, able to analyze the uh, lung cancer. And also we have combined both models also, like image plus symptom analysis, where you can upload an image and also provide the symptoms, and it will give the combined ensemble prediction. Okay, so for the dataset, for the symptom-based dataset, we have used this one, which is a basically a complete dataset which has been created by a very good organization, and it's open source, so anyone can use this. Okay, so we have utilized this dataset which has a very good number of records and number of size of dataset. Okay, and for the training, we have also created a notebook where we have trained the model, we have performed different analysis, okay, feature engineering, and done the feature extraction and pre-processing, and trained some all machine learning algorithms. And out of that, we have identified some best algorithm, and we have integrated the best one in the web application. Okay, so these are the models which we have been utilized. Okay, and out of that, the random forest was working pretty good. Okay, which was almost 93% accurate. Okay, so we can see this is the overall graph of model accuracies and F1 score in other parameters. Okay, and confusion matrix important feature. So the one of the important feature is mainly age. Age is one of the feature which highly impacting the predictions. Okay, and then we have tried with the live prediction as well. Okay, so this is a notebook for uh, behavior-based prediction. Similarly, for the lung cancer tumor detection, we have used this dataset, which is a very huge number of images are there, almost 5,500. Okay, so we have used this particular dataset from RoboFlow, which is already labeled data are there. Okay, and out of that, we have used the latest YOLO version 11 algorithm, which is the latest one to train the model. Okay, and this is the notebook for training the model. We have used Google Colab to train the model as it provides the GPU. Okay, and these are the some information key. There are this number of training images, validation images, test images. Okay, like that. And then we have done some analysis also. Okay, and then we have done the some visualization of available images, and then we have trained the model YOLO algorithm. And in the YOLO algorithm, we have keep 50 epochs, and we have got almost 98% accuracy. Okay, which is very good accuracy. Okay. Okay, this is the overall graphs related to YOLO algorithm. Okay, and this is the some live predictions. So this way we have done with this image part. Okay, all graphs are being saved in this particular folder, so you will be able to find in folder. Okay, so this is the web application we have also created where you can provide a live input. Okay, just let me reference this. So first we'll do the image analysis. So you can just select the image. You have to click on image. I have provided you some sample images, so you can select it from here, or you can uh, find it with other data sets as well. Okay, let's suppose upload some this image. Okay, random image. So as you can see, this is the original and this is the detection result. So as you can see, it seems like there is a tumor or there is a cancer in this particular area. So our system has detected this particular area and also highlighted key where is the cancer. And here are some information or confidence key, how much confidence our algorithm are there to uh, how much average confidence of this particular prediction. Okay, like that. Same, you can upload some other images also, like this one is some of the image. So it also has some this area where infection has been spread. Okay, this is one of the image. Okay, just let me look for some clean image, clean lung image, which should not have disease. I think it look like, yeah. So as you can see, this is this image of X-ray of lung. It's pretty clean. There is no some tumor or nothing is there, right? So our algorithm has also not predicted any tumor or something. It is saying it is negative cancer. That means ki no cancer lung detected. Okay. Same way you can go for symptoms analysis. You can select these features. Okay, and then you can click to analyze symptoms as for the your general lifestyle. You can select this. Okay, and you can play with this particular features. Let's keep it 50 and let's say ki yeah, smoking. Yellow finger, yes. Keep anxiety and let's try. Okay, so I have made something which should look like patient is suffering from cancer, just like I have mentioned, higher age, smoking, yellow finger, anxiety. Like that you can select the symptoms and you will get the prediction just like this one. Okay, with the probability. And in the combined model you have to upload the x-ray image, just like let's suppose I'm uploading some x-ray image, this one. Okay, and then you have to click the you have to select these parameters, just like I'm smoking. Yes, open great. Let's select some random values. Okay, as of now, and total years, and let's try. So in the combined prediction, you will get the image-based prediction as well as the symptom-based prediction. So this way, you will get the combined both image and cancer features combined prediction. Okay. So you have to play with this particular symptom based analysis. Okay, mainly I have seen as higher age you grow, the lung cancer disease chances increased. Okay, so this way we have done all this lung cancer detection particular system. Okay, so yeah, do let me know in case any doubt or anything you have. Thank you.
Thank you friends for watching my video. If you are new then subscribe channel and share with your friend. Don't forget to like, comment and share. Thank you.